Hello everybody and welcome back to the channel. In this video, we are going to cover NumPy in as much detail as we possibly can. And hopefully by the end of the video, you're going to have a great and vast understanding of this wonderful Python library. So you know what, let's just get right into it and discuss exactly what is NumPy. Well, very simply put, NumPy is a Python library that is used to work with arrays. Whether we want to query arrays or perform complex operations on them, we probably want to use a library like NumPy. Now, specifically, NumPy allows us to work with n-dimensional arrays. So what do I mean by that? Well, let's look at this array right over here. This is probably the typical array that we see. So we have an array and then within it we have a bunch of different integers. This over here is a one-dimensional array. But we can also have an array that looks like this. So we have an array and then within it we have a bunch of different arrays of integers. This right over here, because we have this nested array, is actually a two-dimensional array. And we can keep going and going and going. So we can have an array within an array within an array. This over here is a three-dimensional array or a 3D array. And NumPy is an excellent library for dealing with these more complicated arrays. But that actually begs the question, why do I want to use NumPy over just Python? Because we can do all of these things with Python lists. Now there's a multitude of reasons why we want to use NumPy over Python, and we'll actually get through a lot of them in this video. But the main reason why we want to use NumPy over Python for dealing with large and complex arrays is speed. So NumPy is significantly faster for traversing an array than NumPy traversing a list. And the main reason for that is how much memory is stored for each particular variable. So for example, let's say we have a variable that is equal to 7. Now let's think that in Python, how much memory we need to store for this particular number, just the number 7. So in Python, we need to store the size of this number. We also need to store the count of this number. We also need to store the type, whether it's an integer or a boolean or a string, etc. And we also have to store the reference. So for just this one number right over here, 7, the binary can look something like this. Now it's not exactly this. This is just a bunch of gibberish that I made up. But because we're storing so much stuff, the binary can look something like this. Whereas with NumPy, we only care about the size. So instead, the binary looks something like so. So you can see it takes up significantly less bytes. And because it takes up significantly less bytes, it is going to be way faster to traverse an array in NumPy rather than a list in Python. So that's one reason why it's significantly faster. There's actually a bunch of other reasons, but that is the main one. Now, another huge benefit with NumPy is we get a lot of really cool operations that we can do with a NumPy array that we cannot do with a Python list. So for example, and don't mind my cat, he's just playing around with something on the floor. So for example, over here, let's say we have 3 different lists or 4 different lists, and each list indicates how much money I made on a particular day of a particular week. So the first week on Monday, I made $304. On Tuesday, I made $424. Wednesday, Thursday, Friday, Saturday, Sunday. And then over here, this is week 2. This is how much I made on Monday, Tuesday, etc., etc. You guys get the point. So I have this list right over here. And let's say I want to create another variable. I want a variable that is the total income per day for that whole particular month. So I want something where I can get all of these variables, and then for each Monday, I want to add these numbers together. So you can see here, this right over here is that index of 0. I want to add this with this, with this, with this. And so I can have one array that has the sum of all of these numbers for index 0. I can have for index 1, I can have the sum of all of these numbers, etc., etc., etc. So something that looks ultimately like this. Now, it would be really, really easy if we can just do something like so. So total income per day, and we can just add all of the lists together. However, in Python, that kind of leads to a huge disaster. It leads to concatenation rather than adding each particular number at each index. And that's something that we actually probably want to do. We want to have these types of operations when we want to deal with these large arrays. And that is something that, well, NumPy fixes. So if we actually convert each one of these into a NumPy array rather than a Python list, and then we perform this operation, then we get exactly what we intended. So that is just one thing that we get from NumPy that we don't get from a Python list, and something that we probably do want. Now, this is just one example. We're going to look at a bunch of different examples. For example, we can multiply, we can divide, and there's a bunch of other things that we can do with NumPy rather than a Python list. But this is just one example to show you the powers of NumPy and why we would want to use it. All right, so that's pretty much it. That's enough of the concept. Let's actually go ahead and start coding with NumPy. In order to get started with NumPy, I actually went ahead and opened up a Jupyter notebook. Now, of course, if you want to follow this tutorial, you're going to need to have Python installed as well as NumPy. The easiest thing to do to install everything at once is just to install the Anaconda distribution. And what you do is you get Python as well as a lot of the really common Python packages like NumPy, Jupyter, Pandas, etc. So if you go ahead and install this, it's going to be relatively easy. Then you can open up your Jupyter notebook through Anaconda, and you can get started with working with NumPy. So the first thing that we need to do, now that we have installed it through Anaconda, the first thing that we need to do is into our Jupyter notebook, we need to import NumPy. So what we're going to say is import, and we're going to say import NumPy. And typically we import NumPy as NP. So we can refer to NumPy as NP rather than NumPy. And then do Shift Enter, and that is going to actually go ahead and import it. So the first thing that I want to talk about is how we can create different NumPy arrays. And there's two different ways we can do this. We can just create a NumPy array using the NumPy method, or what we can do is to convert an existing Python list to a NumPy array. So let's begin with that first. So over here, let's say I want to create a list. So this is just a regular Python list. So over here we have a list, and over here, let's just say we have a list of numbers from 1 to 5. Let's do Shift Enter to create this. And if I were to say my list, it shows me the list like so. I can also check the type of the list to make sure that it is indeed a Python list. As you can see here, we have Python list. Now what I want to do is I want to convert this into a NumPy array. How do I do that? Well, I can actually do that very, very easily by saying np.array, and then inside of these quotation marks, because we're invoking it like it's a method, because it is a method, we can say my list. We can pass in my list. And there we go. You can see now the syntax is a little bit different. We have converted this Python list into a NumPy array. Now, if I went ahead and I did my list again, and then I did Shift Enter, you can see that this is still a list. Now this over here, this operation didn't convert this variable into a NumPy array. So what we're going to need to do is probably reassign it to something like my array is equal to, and I can say here, my array. And now if I did my array, we get our NumPy array. And if I did the type of my array, you can see that it is indeed a NumPy array. All right, so that is looking really good. Now we can also, of course, convert multi-dimensional arrays. So let's say over here, I create a list called my matrix, which consists of an array of 2 arrays. And then each array has, let's just say, a set of numbers. So let's say 1, 2, 3, and then over here 4, 5, 6. So this right here is just a regular Python list. And what we can do here is actually convert this into my matrix, so I can convert this into a NumPy array, and you can see that NumPy actually has the concept of dimensionality. So you can see that it understands, because over here we have a two-dimensional array, that it is actually going to go ahead and separate them into columns and rows like so. So that's kind of cool. All right, so that's pretty much all it is that we need to know. Let's go over here and let's actually add this into a variable. So I'm going to say my 2D array is equal to this. And now that we have converted all of these things into arrays, we can actually use different properties to get some information about these arrays. So for example, maybe I want to figure out, what dimension is this array? I mean, I can probably tell from the variable name, but let's say I don't, maybe my variable name is just array. What I can actually do is something like my 2D array dot n dimension, and you can see it outputs 2. If I went ahead and said my array, which is this one over here, and I got its dimension, so dot n dimension, you can see that it outputs 1. And we can also actually look at different properties like the shape, for example. So over here, let's just say my 2D array dot shape, and it actually tells us that it is 2 by 3. So you can see here it tells us that it has 2 rows and 3 columns. Really, really cool stuff actually. Okay, and we can also of course do the exact same thing with my array dot shape. Let's just do it here, my array dot shape. You can see here it's telling us that it is 5 by, well, nothing by comma, and that indicates that it is just a one-dimensional array with 5 elements. Okay, so that is how we can convert an existing Python list to a NumPy array. But now let's talk about how we can just create a NumPy array outright. So to create a NumPy array, there's another method that we're going to use called arange. And notice over here that we only have one R, so it's a range. And then in here, we're going to supply it with some values. So we're going to supply it with the first number that we want to add, and then the last number right over here. And what this is going to do is it's going to create a NumPy array with 0 to 10, but not including 10. So from 0 to 10, but not including 10. Let me just show you how that looks like. So over here now we have 0, 1, 2, 3, 4, and then all the way to 9, but not including 10. So this number over here is exclusive, and this number over here is inclusive. So we're going to include this number, and then we're going to go all the way up to this number, but not including it. So that's just an important thing to understand. Now, if we, for example, want, from 0 to 10, then what we would do is very simply say np dot arange, and then from 0 to 11. Or maybe if we want to go, let's say from 1 to 10, we would say from 1 to 11 like so. And there we go, we get 1 to 11. Now let's say what we want to do is maybe we want to get all of the even numbers. So all of the even numbers between, let's say 0 and 10. So how do we do that? Well, we can say np.arange, and we can say 0 to 11, but I want you to skip 2 elements. So for each particular iteration, we want you to skip 2. And what ends up happening is we get 0, 2, 4, 6, 8, 10. We can of course do the same thing with like 3, and that's going to give us 3, 6, 9, and then that's about it. So hopefully that kind of gets the message across. All right, so that's pretty much how we can create NumPy arrays. Now, there's other things that we might want to do. Sometimes we probably just want to create the array itself, and we don't really care about the values within it. We really maybe just care about the array or the array shape. So what we can do here is do something like np.zeros, and then over here, we can say 5. And what this is going to do is it's going to create an array with 5 different zeros. And again, this is just for, hey, I don't really care about what's in there. I just want the shape itself. So I'm just going to add zeros in there. And of course, we can actually really manipulate the shape. So let's say np.zeros. And if over here, we can, instead of adding just a single number, we can add a tuple. And we can say I want a 5 by 5. And you can see here, now we get a 5 by 5. So 5 rows, 5 columns. And we can really manipulate this however way we want. So for example, let's say I want a 5 by 5 by 5, which is going to be a 3-dimensional array. And there we go. You can see that's exactly what we get. It's a little bit long, but hey, that's what we get. Okay, so that is pretty much all it is that we want here. Another thing that we can actually talk about is, instead of zeros, we might want to add ones. So instead of np.zeros, we can actually have a very similar method, which is going to be np.ones. And this pretty much does the exact same thing. So we can go over here, do this, but this time instead it's ones instead of zeros. All right. Now, sometimes we want to generate arrays that have random numbers. So to do this, what we can actually do here is say np.random, and then we say .rand. And what this is going to do is give us, let's say, 5 numbers that are going to be completely random from 0 to 1. So if I went ahead and I did this, you can see here that I have, well, this random number that's between 0 and 1, this random number that's between 0 and 1, etc., etc. Now, your numbers should be, of course, different because they are completely random. Now, of course, we can also define the type of array that we want. Let's say I want, similarly to what we did above, we can say np.random.rand, and I can say that I want maybe a 2 or a 5 by 2, something like that. And then over here, I can, as you can see, I get 5 rows, 2 columns of just these random numbers. Now, let's say I want some, hard integers, not these decimals, between, a value that I specify, between a range that I've specified. And we can actually do that. So over here, what we can do is we can say np.random, and then we can say rand int, which is going to give us an integer value. And then in here, we can say something like, I want a random integer from 0 to 101. So over here, this is going to include 0. And this is over here, it's going to be exclusive. And then I can say how many numbers I want, which is 10 numbers. So I want 10 random numbers in an array that are between this range over here. And as you can see, this is exactly what we get. So we get this array right over here, some nice hard numbers. Now, of course, we can also define the shape of this. So we can go over here, and instead of just saying 10 like so, we can define a tuple, and we can say 10 by 5, for example. And we can see we get all of these random numbers like so. Now, sometimes for tutorial purposes, it's actually really nice to generate these random numbers, but have the random numbers be the same for you and I. So in order to do this, what we can actually do is use a seed. So I can say np.seed or .random.seed, and I can say here 42. I can use any arbitrary number over here, and then don't do a shift enter in the same exact cell. Then do np.random.randint, and I want some random numbers between let's say 1 and 100, and I want 10 of them. So if I went ahead and did this, you can see here that we get this array. And if you did this exact same cell right over here, exact same lines of code, you should have these exact same random numbers. And that's because of this seed. And I added 42 here, but this could be any number it is that we want. But if I change the number, it's going to change the outcome. But if I leave this number, the outcome is going to be exactly the same. So for example, if I run this in another cell or a different computer, you can see the outcome is always going to be the same. But if I change this, for example, to let's say 23, and I run it, you can see that this is going to have a different array because now we have changed this arbitrary value. And if I run this again, of course, and if you run it on your machine, you should have these exact same values. So this is how we can actually just generate these random numbers, but have them be consistent maybe across multiple people. Okay, So the last thing that I want to talk about is, now that we know how we can generate these arrays, we can start actually using some different methods on the arrays themselves. So for example, what we can do here is, let's just say we have my array, and let's actually copy this over here. And let's just say my array is equal to this right over here. Now, if I were to look at my array, you should see something like so. Now, what I can do if I wanted to is I can say my array dot reshape. So I can actually reshape the array. So I can reshape it from maybe a one-dimensional array to a two-dimensional array. So I can have 2 rows, and then we have 5 columns. And if I were to do enter like this, you can see that now it has been reshaped. Now, one thing that you can't really do is something like this. So you can't do, for example, 3 rows and then 5 columns. Why? Because in that case, we actually need to have 15 elements, whereas we only have 10. So if we try to do this, it's going to throw an error. We only have 10. We can't have a 3 by 5. So we need to make sure that we actually have the correct number of elements when we want to reshape. Now, another thing that we can do is we'll figure out maybe the min value. So we can say my array dot min. That's going to give us 26. I can also say my array dot max. That's going to give us 92. We can also say my array dot mean to get the average. We can say my array dot std to get the standard deviation, and etc, etc. So there's a bunch of different little methods that we can utilize to get more information about our array. Now that we know all the different ways that we can create NumPy arrays, let's move on to a different topic. And this topic is going to be selection and indexing. So let's go back to our Jupyter notebook over here. And I'm just going to create a NumPy array that is going to have the numbers from 0 to 10. So let's go over here. Let's just do NumPy or np.arange. And we're going to say 0 to 11, because remember, it's including 0, but not including 11. So let's go ahead and create this. And np is invalid syntax. Let's just go over here and let me just shift tab this again. And let's try that again. Oh, of course. Never mind. I should be doing equal here. And there we go. We should have our wonderful NumPy array. So now let's say that I want to select this element right over here. So inside of this array, I want this number 4. Now, how would we do this? Well, we do it the same way that we would inside of a Python list. We do it with the index. So what is the index of this particular number right over here, this element? Well, it just so happens that the index is also 4. So 0, 1, 2, 3, 4. So in order to get that specific number, all we have to do is array and then square brackets and then the index, which is 4. And there we go. You can see here we have the number 4. All right, and now if we want, of course, another number, let's say we want 7. Again, it just so happens that the index of these numbers are going to match the actual elements themselves. So over here, we can just say array of 7, and we get 7. Now, one cool thing that we can also do, and we can also do this in Python, is we can actually start, rather than from the beginning of the array, we can actually start from the end of the array by using negative values. So let's say we want to get this number over here, 10. So we could do it by doing something like this. So array of 10, and that's going to give us 10, starting from the beginning all the way to the end. Or we can also do array of -1, and by using a negative number, we're going to start from the end, and -1 is going to symbolize this very first element right over here. Now, let's say we wanted, 5. We would do -1, 2, 3, 4, 5, 6. So this will be -6. So you can say -6, and that's going to give us 5. So that's just another way that we can select specific elements. But most of the time, we're not going to want to select a specific element. We're going to want to select maybe a range of elements. So for example, we might want, all of the numbers from 4 to 7. We want to get those numbers right over here. So all of the numbers from the index of 4 all the way to the index of 7. So how would we do that? Well, what we can do here is we can have our typical selection array, and then we can say, I want all of the numbers that is going to be starting from index of 4, and then we're going to say 8, because this is kind of similar to what we've done before. It's going to include 4, but it's not going to include 8. And if we went ahead and did that, you can see we have 4, 5, 6, and 7. All right. Another thing that we can also do is, for example, we can say array of 0 to 8. This is going to give us all of the numbers from index 0 to index 7. And if we went ahead and did that, you can see that, well, this is exactly what we expect. Now, because 0 is the very very beginning of the array, what we can actually do to kind of make this a little bit shorter is actually not include that 0 and just say :8. And what this is going to mean is everything from the beginning of the array to index of 7. So that's going to give us the exact same output. And of course, we can actually do this the other way around as well. So we can say something like, so from index of 5 to the end of the array. And then over here, we can just get from index of 5 all the way to index of 10. All right, and this is actually pretty good because, well, that way we don't have to know, how many elements we have in our array. We don't have to kind of determine that. We can just say, just give us everything from 5 forward. Okay, so that is pretty good. If we want to get all of the elements of the array, we can also do just array. Or if we just wanted to, just for the heck of it, we can just say : like so. And that's just going to give us everything from the beginning all the way to the end. Now let's look at querying specific slices or elements with a 2-dimensional or maybe a 3-dimensional array. Let's just do 2-dimensional for now. So let's create a 2D array, and let's just use the random here. So we're going to say rand int, and over here we're going to say we want the numbers to be from 10 to 100. So we're going to say 101 because it's not going to include 101. And then let's define the shape of this to be 3 by 3. And so now if I did 2D, you can see we have a 2-dimensional array. Okay, so let's say that we want to get the first row right over here. So we want all of the elements inside of this first row. So we want to return this actual array. So in order to do this, what we would do here is we would do something like so. So we would specify the row as the first square bracket, which is going to be the index. And then if we want to get a specific element within that row, we would specify the column as a second set of square brackets. But this time we actually do not want to get a specific element. We just want to get the whole row itself. So we actually do not need to specify this. And we can say that this is going to be the first index. And if we went ahead and did that, you can see we have, well, that row right over here. Now let's just say we want to get maybe this number right in the middle. Well, that's going to be the row of index of 1, and then the column is going to be also having an index of 1 as well. So in that case, we would do something like so. So we do 1, 1, and there we go, we get 59. Now, another way of doing the exact same thing, so we can just save us some space, is by saying 1, 1. So syntactically, this is exactly the same as this over here. It's going to achieve the exact same outcome, but this is probably a little more elegant and faster to write. So as you can see, everything is fine. Another thing that we can also do is something very similar to slicing. So we can, of course, slice multi-dimensional arrays as well. So let's say what we want is maybe, so we want to get these two rows over here, but we don't want to get the first column. We only want to get these columns. So the second and the third column, which correspond to index 1 and index 2. So I want to have only these two rows, not this row right over here, but within only these two rows, I just want these numbers in each row. So this is actually relatively simple to do. All we have to do is just say, well, array 2D, and then we're going to say, well, we want the first two columns. So in order to specify that, we're going to say 0, 2, because that is going to get, well, start from 0, and this is the second index, but it's not including that, so it's going to be from 0 to 1. And that's going to give us, well, at least the first two rows. Now, of course, we can actually simplify this to something like that. And that way we get, well, the first two rows, same exact thing, but now we don't have to add that 0. But now what we want to do is within those two rows, we want to get the two columns. So over here, what we can actually do is say, well, I want to get from index of 1. Oops. What happened here? What happened here? I changed this to Markdown. All right, let's go ahead and run that again. So over here, we can say from index of 1 onwards. And there we go. That's not actually what we want here. So what we're going to do instead is actually put this inside here. So we're going to say comma, and we're going to say index of 1 onwards. So the issue with actually putting it back there is not then we're actually slicing the row itself. But now you can see here we get 16, 55, 59, 56. Okay, so that is, well, how we can select specific elements or slices of elements. So now let's actually move on to broadcasting. So let's go over here to our array. So remember, this is how our array looks like. And one thing that is actually really cool that we can do is broadcast a specific number to all of these or a slice of this array. So over here, what we can do, for example, is say, let's say from 4 to the index of 5, I want to change all of these numbers to be equal to 10. And now if I went and I showed you the array, you can see from 4 to 5, the numbers have now changed to 10. So they used to be 4 and 5, now they're 10 and 10. So that right there is broadcasting. We're broadcasting this particular number to a slice of this array. And it's actually mutating that array to that number, which is actually something that we cannot do in Python. Now, another thing that might actually confuse some people is sometimes people, they want to get a slice of this array and then assign it to a particular variable. So we can say slice of array, and then we can say that that is equal to, let's say we want to get this slice right over here. So we can say here array of from 0 to 4. And if I were to say slice of array, you can see here we have 0 to 4. Now, what actually confuses people is sometimes they like to broadcast, or sometimes they go ahead and broadcast the elements inside of this slice of array. And let's just say we want to change everything inside of this array to 33. Now, if I went ahead and I looked at the slice of array, you can see that everything has actually been changed to 33. However, if I actually went and I looked at the original array as well, you can see that those numbers also were changed to 33. So this is something that is actually very important to note. When we do something like this or something like this, what this is doing is it's not creating a new array, it's just pointing to the original array as a reference. So if I go ahead and I actually mutate this array, because it is just simply a reference of the original array, that is also going to mutate this one as well. All right, so I hope that is clear. Now, if that's not like a behavior that you want, what you can actually do is create a copy. So over here, let's just say slice of array and then copy. And then over here, let's just get all of these numbers over here. So we're going to say array from index of 6 onwards. And then we have to specify dot copy. And now if I did slice of array underscore copy, you can see here we get 6 to 10. And if I were to change this to, let's say 99, and I were to now say slice of array copy, you can see that that changes all the way to 99, but nothing changes inside of the original array because this time this is not a reference, it is a copy. It is a brand new array. Okay, so that pretty much sums that up. Now, one thing I do want to note is conditional querying, conditional rendering of a specific element. So let's just go over here and let's just say I want to get all of the elements that are larger than 10. So I want to get or maybe larger than 9. So I should get all of these elements right over here, including this one. So this one, this one, this one, this one, this one, this one, as well as this one. But these 4 over here, I shouldn't get. Now, one thing that I can actually do here is I can say array is greater than 9. And what that's going to do is give me a NumPy array of Boolean values. So you can see here, this one's true, this one's true, 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 whereas these 4 over here are false, and then this one is true. And I can actually use this expression now like so. So I can say array, and then over here I can say array is greater than 9, and now you can see we have 33, 33, 33, 10, 10, 10, and that is how we can actually conditionally select any particular element based on, well, a condition that we have specified. The last thing that I want to discuss are operations. So let's go back to our Jupyter notebook, and I am going to create a brand new array. So let's just say array is equal to mp.arange from 0 to 11. And if you look at it, we have our typical array right over here. Now, what I want to do is I want to perform an operation on this array, specifically an addition operation. So let me just say array plus 5. Now, what is going to happen in this case? Well, what ends up happening is that it performs this operation over here on every single element in this array. So if I were to log this out, you can see that it does 0 plus 5 to give us 5, 1 plus 5 to give us 6, 2 plus 5 to give us 7, etc., etc. So what I'm trying to say is that it performs the operation on every element in the array. Now, of course, we don't only have to do addition. Of course, we can also do subtraction. So we can say subtract by 5, and now you can see it does it on every single one. We can also, of course, do division, maybe divide by 5. We can also do multiplication, and we can, let's say, multiply by 4, and there we go. Now, we can also perform these operations within 2 arrays that have the same shape. So, for example, I can say array plus array, and in effect, that just duplicates each element inside of this array. So, in essence, this is just like doing array multiplied by 2. Now, as you can imagine, if I do array minus array, I'm just going to get a bunch of zeros. Of course, I can also do array times array, which is going to give us the square of each element. And then we can also do array divided by array. And this is actually going to give us an interesting value over here. So you can see here that we have divided everything, and everything is 1, which makes sense, except right over here where we did 0 divided by 0. So if we do 0 divided by 0, what ends up happening is we actually get an array. However, this first element over here where we did 0 divided by 0 is actually going to give us not a number. And this is just a warning. It's not an error. It's just a warning. And it's just saying that, hey, this over here, this first element is not a number. So if you go ahead and you ever divide anything by 0, so if you divide 0 by 0, you get not a number. But if you divide anything else by 0, you actually get infinity. You still get the same warning, but you get infinity. So for example, let's just say we have, let's say 3 divided by our array. You can see here, this time we get infinity. We still get the same exact warning. And we have all the other values working, of course, but the value that we divided by 0 is infinity. So if we did 0 divided by 0, we get not a number. If we do a number divided by 0, we get infinity. So this is just something to watch out for. Okay, so now let's actually go ahead and move on to some of the built-in methods that we can actually use to perform operations. So I'm going to go over here and I am going to create, well, let's just use our same array. We've seen this before. We can use, the dot mean to get the average. We can also do, what we can do is we can actually perform operations on every single element in this array by doing something like, let's say I want to get the square root of the array. So I can say np dot square root, and we can perform that on every single element in the array. You can also do something like sine of the array, which does the exact same thing. Another thing that we also can do And let's actually go ahead and create a two-dimensional array for this. So I'm going to say 2D, and let's just say np.random.randint. Let's just say from 10 to 100, and let's define the shape of this, which is 2D. So let's just go ahead and take a look at this. We could do some really cool operations with 2D arrays. So for example, we can do something like, well, 2D.sum. And if I were to log this, you can see it actually gets the sum of every single value inside of this 2D array. So regardless in which array that they're in, which nested array that it's in, it's just going to get them and sum them all up. But we can actually start doing some really cool stuff. So maybe what we want to do is we want to get, let's say, the sum of each row in this array. So what I can do here is I can do something like array 2D dot sum, and then I can actually specify the axis. So if I want the, let's say the x-axis, I'll say 1, like so. And as you can see here, that's going to give me 96, which is going to be the sum of this row right over here, and then 89, which is going to be the sum of this row. Now, if I want the sum of the columns, so this plus this, and then this plus this, I can change the axis to 0, which is going to be the y-axis. So let's go here. We're going to say dot sum, and we're going to say axis is equal to 0. And there we go. So now we have these two added up. 74 plus 31 is 105. And then over here, we can say, well, 22 plus 58 is 80. Now, of course, we can actually do this with anything. So we can do this with the mean as well. It doesn't have to necessarily be the sum. So we can say 2D dot mean. And this is just going to give us the mean of everything. But of course, we can also specify the axes if we want. So if you want, let's say, on the row level, we can get this. That's going to give us the average of each particular row. Basically, it's going to add them and then divide them by 2. And of course, over here, we can change the axis to 0. And then we have the column means. So that is pretty much really all it is that you need to know. There's a bunch of different methods that we can utilize. You can go to the NumPy documentation to read all about them. We're not going to go over every single one because that will just be pretty repetitive. And really, if you need them, you just go ahead and search them. Search on Stack Overflow, and you'll probably get a method. So I hope that actually makes a lot of sense, and that helps you in your NumPy journey.